Here we have a question involving arcsine and sine. It's a composition of trig functions. Let me write it out a little bit better. Arcsine of sine of minus 2 pi. Oh, minus 2 pi over 7. Better get that straight. Minus 2 pi over 7. Okay, arcsine is another way of saying sine inverse. It's the same thing. Arcsine is sine inverse. Just two different languages for saying the same thing there. Okay, two different words for the same thing. It's not a language, it's a word. All right, anyway, so what does this equal? Inverse sine of negative 2 pi over 7. Well, doesn't it seem like these should just cancel each other out? Because they are inverse functions. And the truth is that's basically right, usually. And the usually is the problem, and it's actually a pretty tough problem. So I've written up a whole series of notes to help you know when that's the case. Let's take a look. So the notes for this, which took lots of hours to write, I'm glad to do it. It's just, I hope you benefit from it. Composition of the same. So here it is. Composition of the same and inverse inverse and regular trig functions. So sine inverse of sine. Do they just cancel out? Yes, that is true in this particular case, but not always. How do we know? Here's the step. Step 1. Figure out if it is an angle or an answer that is inside the parentheses. Little typo there. Figure out if it's an angle or an answer that's in the parentheses. What do we mean? Remember that we plug angles into sine, cos, and tangent, but answers into these. So let's go take a look. Is this an angle or an answer? This right here. Well, it's you might say, well, it's an angle. It's got a pi. Careful. It's not that simple. Pi is just a number. 3.14. Pi could be a number or an angle. You can't tell just from that. It depends on where it sits. It's sitting inside of a sine, right? Let's put it that way. It's inside. It's immediately inside of a sine function, which means so it's an angle, right? We put angles, right? We put angles like, pi over 3. We get an answer, root 3 over 2. And for inverse trig functions, we put in answers, don't we? And we get out angles. So we put in angles to sine. So this is inside of a sine. It must be an angle. So it's an angle. So that's our first order of business. Let's go back. So decide if it's an answer or an angle. Ours is an angle. Okay. Let's go to the next piece of information. Figure out if it is within the different limited domains. So now here we go. There's domains for the different trig functions. What are we talking about? We're talking about sine with an angle. Is it between negative pi over 2 and pi over 2? Is it? Is it between negative pi over 2 and pi over 2? So that's the question. Is negative 2 pi over 7 between negative pi over 2 and positive pi over 2? I hope you know the answer is yes, because think about it. This, if you're doing a number line, this is negative 1 pi over 2. It's half a pi. And this is positive half pi. Here's 0. Negative 2/7 has got to be somewhere around here, right? Because 2/7 is between 0 and a half. If you said, I ate 2/7 of the pie last night, that's less than half, isn't it? 2/7 is less than half. So yes, it's between those. Of course, you could plug in, decimals, but can we just think 2/7 is less than a half, right? 2/7 of a pi is less than half the pi. So yes, it's between 0 and negative a half. It's a negative number. So yes, it's between, it's in the domain. It's in the limited domain. Let's go back to the notes. So is it between these? Yes. Yes. If it is within the limited domain, then the inverse function and right function cancel, and the answer is the same as what was in the parentheses. For example, these just cancel. It's 0.75 because 0.75 is in the range. All right. So that gives us our answer. So these do just cancel. And the answer is, let me erase this, just negative 2 pi over 7, because they just cancel out. because it's an angle, first off, and it is in the limited domain. So yes, there we go.